Bright Tuty. Every student matters.
Now let's just quickly discuss some of the questions so that we can see what we have learned about quadrilaterals. So these are the questions that we have to solve, which are just based on the quadrilaterals, right? So here the first one says true or false. In the first one, part A, it says each angle of a right angle is each angle of a rectangle is a right angle. So the answer is true. Yes, each of the angle of a right angle of a rectangle is a right angle, right? Now the B part says the opposite sides of a rectangle are equal in length. The opposite sides of a rectangle are equal in length. So what do you think? The opposite sides of a rectangle are very much equal and parallel. So this statement is again true. Now the third one says the diagonals of a square are perpendicular to one another. The diagonals of a square are perpendicular to one another. For this, I think we should quickly make a drawing in here of a square. We know that diagonals of a rhombus are forming a perpendicular in between. Let's see the same for the square as well. So here is the first diagonal. Okay. Now let's draw another diagonal here. Okay, so what do we notice in this shape is that the diagonals of a square, when they intersect each other at the center, clearly they are making a 90 degrees angle. This is something you have to remember very clearly, that the diagonals of a square do intersect at the center, making 90 degrees angle. So again, the statement here is very much true. Now the D part. All the sides of a rhombus are equal in length. So what is the answer? I hope you remember rhombus is just a squashed square. So yes, all the sides are equal. So it's again true. Now the E part, all the sides of a parallelogram are equal in length. What do you think? I'll just show you an image of a parallelogram here and then you decide it yourself. So this here is a parallelogram. Do you think all the sides are equal? The answer is no. Only the opposite sides, the pair of opposite sides are equal and parallel. So here the statement is false. Now the last one, the opposite sides of a trapezium are parallel. Just one pair of opposite sides of a trapezium are parallel, not all the four sides. This is how a trapezium looks like. So clearly the opposite sides of trapezium are parallel, but only one set of opposite sides, right? Not the other one. So we are not very much sure what they are asking us. Are they asking about both the pairs or are they asking us about just one pair? So to be on the safer side, we'll say the statement is false. Why? Because it is not true for all the sides. Because just one pair is parallel, not the other one. So we'll say the statement is false. Now here we have to give the reason for the following. The first one is a square can be thought as a special rectangle. What do you think? A square can be thought of a special rectangle. So think about a square and think about a rectangle. If we want square to be a special rectangle, whatever properties a rectangle is satisfying, everything should be satisfied in a square as well. Okay, so what are the properties of rectangle? 1. The opposite sides needs to be parallel and they need to be equal, right? So are these two properties satisfied in square? Answer is yes. So all the opposite pairs we see in square, they are the two pair of opposite sides in square we see they are parallel and they are equal as well, right? And in rectangle, we also have the property that all the angles formed, the interior angles, they all are meeting at 90 degrees. So do we have this in our square as well? Do all the angles, all the four interior angles in square all 90 degrees in measure? The answer is yes. So the statement is true that a square can be thought as a special rectangle. And the reason behind this is that all the properties of a rectangle are satisfied for a square. In addition, that in a square, not just the opposite pair, but also all the four sides are equal to each other. I hope this is clear. Let me repeat the reason why a square is a special rectangle. Because all the conditions of all the properties, instead we should say, all the properties of a rectangle are fulfilled by a square. In addition, that all the four sides of a square are equal in length. Now moving to the next one. A rectangle can be thought as a special parallelogram. So what are the properties of a parallelogram? The parallelogram needs to have the opposite sides equal and parallel. So yes, all the properties that we know about a parallelogram are satisfied by a rectangle. In addition, what do we have? That the angles, the interior angles in a rectangle are 90 degrees each. So this is something which is in addition to a parallelogram. So rectangle is a special parallelogram. Is that clear? Now let's see the C part. A square can be thought as a special rhombus. So I hope you remember how a rhombus looks like. It is a squash square, and square, it's like a rigid shape, right? So what property do a rhombus have? Rhombus needs to be having all the four sides equal. Yes, this is there in square. Rhombus needs to have opposite sides parallel and equal. So yes, this is also true for square. The rhombus needs to have the opposite set of pairs of angle equal, and this is also true for square. In addition, what do we have for square is that all the angles of a square, they are meeting at 90 degrees. Also, rhombus needs to have the diagonals meeting at the center at 90 degrees. So this is also true for square. So we can say that square is a special rhombus. Only the additional property we have for a square is that instead of just opposite pair of angles being equal, all the pair of angles are equal. Okay. Now coming to the D part. Squares, rectangles, parallelograms are all quadrilaterals. Is that true? What is the property of a quadrilateral? It just says that if you give me a closed shape with four sides, I'm good to go as a quadrilateral. And yes, that's true for a parallelogram. It has got four sides. Rectangles have got four sides and square has got four sides as well. So yes, the reason behind this particular statement is that because all these shapes, that is square, rectangle, parallelogram, they all have got four sides. Therefore, they are all quadrilaterals. Now coming to the last one, square is also a parallelogram. Is that true? Yes, a parallelogram needs to have the opposite pair of sides equal and parallel, and this particular property is very much satisfied for square. So square is also a parallelogram. It is a special case of parallelogram. I hope you are clear with this, what we have just learned. Now let's move to the third one. Here it says a figure is said to be regular if its sides are equal in length and angles are equal in measure. Very important point to remember. What is a regular shape? What is a regular shape? Listen to this carefully. Regular shapes are those which has got equal length and angles are also equal. So all the sides and all the angles should be equal. Only then the shape can be called as a regular shape. Look at the first image, this triangle. This is an equilateral triangle. All the three sides in this yellow triangle are equal to each other. And we know in an equilateral triangle, the measure of all three angles measures 60 degrees, right? So all these angles measure 60 and all the sides are of equal length. So this is a regular shape. This is a regular triangle. Now look at the second one. Here, these three sides we cannot say whether they are equal or they are unequal. We just cannot say if they are equal. It looks like they are unequal. Also, clearly by observation, we can say that the three angles formed in this triangle, they're definitely not equal. So what we can say about this shape is that this is irregular triangle. I'll just write it here. This is irregular triangle. This one here. We are talking about this image. Okay, now comes the next one. That is a four-sided shape. Here we can see it is a square in yellow. All the four sides are equal. And the second image is also a quadrilateral because we have got four sides. But this is not a regular shape. In the question it was saying that can you identify the regular quadrilateral here? This particular statement, can you identify if we have any regular quadrilateral in this image? So the answer is this particular image here. This square that I have just scribbled on, this particular image of square is a regular quadrilateral. So I'll just remove this because it's looking very untidy. Okay, so this is a regular quadrilateral because it is a square which is having all the four angles measuring 90 degrees each. So all the angles are equal and all the sides are equal. Okay, moving to the next one. This is a pentagon because it has got five sides and all the five sides are equal. So this is a regular pentagon. I'm just writing R for regular. This is irregular pentagon because the sides are unequal, angles are unequal as well. This is a regular hexagon. This is irregular hexagon. This is a regular hexagon and this is septagon. And this is irregular septagon. This is regular octagon and this is irregular octagon. I hope it is clear that when can we say that a given figure is regular and when it is irregular.